Hello and welcome to a look at some of the experiments you can run with the AE1000V hydroelectric turbine. We will be looking at the effects of flow rate, guide vane angles and propeller variations, and will walk you step by step through the process of setting up and conducting 3 key experiments, so you're fully equipped to run engaging and insightful experiments for your students. In the first experiment we're going to look at, we'll be adjusting the flow rates. Start by making sure the turbine is set at 100% guide rate angle, then switch on the pump and start turning the valve slowly. Then engage one of the lamps and apply load. Now open the valve further and notice that the lamp starts to glow more brightly. We can see the voltage here is getting higher because more water flow is going through the turbine, so it's generating more electricity. Keep turning the valve gradually until you get maximum flow rate. On the control box, start to apply each individual load by switching on the lamps. You can see what happens to speed, current and power generated. Make note of these figures and the different load applied at each stage to compile your results for this experiment. Users can also see the live efficiencies and power loss across the system using the VDAS inbuilt energy auditing tool called Sankey diagram, as shown here. To close the system off, slowly shut off the valve, and once the valve is fully closed you can switch off the pump control and then the mains power. The second experiment will be looking into guide vane angles and their impact. For this experiment we're going to change the guide weight angle, previously set at 100%, now we're going to change it to 80% to see what effect it has. By adjusting the handle manually, you can see the vanes inside the turbine open and close correspondingly. Adjust the handle to 80% exactly, and then we can turn on the equipment and switch on the pump. Slowly turn the valve to let the water in. At this point it will be very noisy due to the differential pressure, but this will reduce as the flow rate increases and thus flow pressure becomes stable. Do this continually until the valve hits the maximum open position, and then you can start engaging the load. Now we can see the speed has dropped and the power has increased slightly as we have loaded the generator to obtain more power. Now we can increase the load by switching on lamps one after another and see what's happening to speed and power generated. Again, take note of each time you increase the load and the readings it generates to form your results for this experiment. To shut off the system, slowly close the valve, and then once it's completely shut, switch off the pump and then the mains. The final experiment looks at propeller variations. Firstly, make sure the pump is off and the mains power is turned off too. Using an Allen key, undo the screws holding the pipe to the turbine and then slowly slide out the outlet pipe away from the propeller. Then remove the current propeller, again using the Allen keys. Gently slide the propeller off the shaft by holding the nose area. Make sure you always handle the propeller using the nose area or the bottom of the hub. Please do not handle the propellers by holding their blades, as this might damage them. There are 5 different propellers included. Select the one you'd like to use first. Then align the step grooves on the shaft and slide the propeller gently on. Make sure the propeller doesn't touch the vane section so that it's free to rotate. And then with an Allen key, tighten the grub screws to secure the propeller on both ends and make sure that it's securely fixed to the shaft. Now take the outlet pipe and slide this into the tank so that it's level with the turbine. Make sure when you push the outlet pipe against the turbine that none of the outside surfaces of the pipe touch the surfaces of the blades. Take it slow until you reach the end of the surface, then when flat against the turbine, adjust the pipe so that the screw holes align by turning the pipe left and right slowly. Then you can replace the screws. Now you can move on to running your experiments. With these 3 experiments, you're fully equipped to engage students in a dynamic learning experience. TecQuipment's AE1000V hydroelectric turbine. Thank you for joining us on this look at the experiments available with the AE1000V hydroelectric turbine, one of TecQuipment's many innovative teaching products helping you to inspire the engineers of tomorrow. For more educational tools and resources, you can visit TecQuipment's official website. Until next time, keep experimenting.